So good morning, my name is Holly-Anna Littlebull. Ollie could not moderate today, so he asked me to step in, so I'll be moderating and also presenting. I'm the Assistant Director of the Northwest Tribal Technical Assistance Program, and those projects are out of the Federal Highway Administration, and there are 7 different TCAPs across the United States and Alaska. I'm the Assistant Director for the one here at the University of Washington. I have Dr. Wei Sun, and then I'll do the introductions when they get ready to speak. What we're going to try to do is, because I saw in the last session questions going on during the presentation made them run over, and so not everything got to be covered. And so what I'll do is we'll just go through our presentations, and then we'll leave the last 15 minutes for questions for each one of us. Whether it's for us individually or for us as a group, we'll answer it at that time so that we make sure that we get you out of here on a timely schedule, and each presenter has equal amount of time. So I work with the different tribes from Washington, Oregon, Idaho, 1 tribe in California, and 2 tribes in Alaska. That's a total of 46 different tribes. 2 of the tribes, the Tolowa from California, have 5 villages in the Oregon states. And the Alaska tribe, Ketchikan, is going to go with Alaska and also with the Northwest TCAP because they're only 20 miles from Metlakatla, and they are in the lower portion of Alaska. And so the one thing that I work with Dr. Wong from University of Washington, Margot Hill from Eastern Washington University. She was a key implement in the original TCAP. If you don't know, that there were some issues and problems with the previous TCAP because they didn't consult with tribes. And basically the tribes boycotted the program and the program fell apart. So some of the issues that I want to talk about will lead into the next conversation. What are the issues in Indian country? Jurisdiction is number 1, first and foremost, because as you can see here in this map, it's outlined in Washington State and the counties. You'll see in the next map, doesn't look like that for tribes. The other thing that we have besides jurisdiction, besides the feds, the states, the counties, the towns, if they're incorporated or unincorporated, there's also BIA roads, there's federal roads, there's tribal roads. So when you're looking at a road, you are not just looking at that road as where it's located, but whose land it's on. Does it have a right-of-way? Does it not have a right-of-way? Is it an abandoned road? And so these issues include collecting data. Well, how do you collect data if the people who collect the data don't give you the data? How do you get access to that? That was a huge issue for us, was getting complete data. And the problem with getting complete data in Indian country is working with the feds, working with the state, working with the counties, the cities, and not being able to have access to that data. For some of the tribes, you have the uniqueness of having military bases on or within their tribal territories. Then you have another jurisdiction to deal with. Most tribes have railroads running through their reservation. That's another jurisdiction. They don't give any data to the tribes on fatalities, pedestrian-related incidences, or even serious injuries. And so it's impossible to, when you're doing your job, where'd it go? And this is a picture, because I'm not really into PowerPoints, but I'm more into pictures, because then you can see what the issue is. This looks pretty simple. It's a state highway, Highway 97. It's the deadliest highway in Washington State, from Union Gap to Goldendale, or to Biggs. This picture shows you US 97, you have reservation in the background, which is closed, by the way. It's not open to the public. You have Wapato Irrigation here, which is another government agency under the Bureau of Indian Affairs, which is also jurisdictional issues, safety issues, because the public will use their maintenance roads for roads. And so then you have no regulation going on because they're just access roads. And when there's waters in those drains or those mains or those canals, there's no guarantee of safety that they will not erode due to water. So it just depends on how much water was that year. The other thing you see up here is open range. There is still open range on most reservations. And if you hit a cow, you hit a horse, and you did it with your car, even if it wasn't your fault, you're paying for that cow or that horse or that buffalo or whatever livestock they're harvesting or growing or breeding. And then this is very common in Indian country. Children utilizing the highways as a means to get from one point to the other. And they skateboard on it, they ride their horses on it, they walk on it, they play Frogger on it, going from the school to get across the highway to go to their community. So this is extremely common. And so the reason why they do it is because there's no sidewalks. If you were in the last session, I was like, you guys are all talking about curbs. We don't have any curbs. We're looking if we have a shoulder. And so this is to show you, look how narrow that shoulder is. I mean, he's almost taking up the whole inside lane. So I was talking about tribal territories. This is tribal territories before jurisdiction came in. I did put the reservations in there in the purple. Those are current reservations. But look how big these territories are. Look how big Nez Perce is. Covers 3 different states. How many different counties? Walla Walla, which is part of the Umatilla. Look at how they're into Oregon and into Washington. Then you have all these other tribes. And then you talk about jurisdiction, here's treaties. That's a whole nother ball of wax. You can go to school for 4 years and not be an expert in federal Indian law. And so that's part of the thing that you have to look at is what type of laws govern the land that you're on, what type of right-of-ways. Is it an easement or a right-of-way? When you're talking with tribal land, it's probably an easement. Why? Because they didn't pay for the right-of-way, so it went away. So these are the tribes that I work with in Washington, Oregon, and Idaho. I haven't added in California because they just requested last week to be a part of our TTAP. And I didn't include Sitka because they just also asked. So this is what I'm required to do. Provide technical assistance, help with program management, give them technology, give them training and education in the different fields, and then help network those tribes with private entities, public entities, businesses, nonprofit organizations, anybody that works in transportation, and how that affects tribes. And so that's a huge area when you're looking at tribes who may not even have a transportation plan or a current transportation plan. Maybe it's expired. Maybe they don't have long-range plans. And then the other thing you have to look at is, yeah, it's great here in Seattle. You can get from anywhere to anywhere via plane, train, bus, Uber, Lyft. Come to Yakima. Good luck getting a Lyft. Good luck getting an Uber. I heard there's 4 total drivers now between Uber and Lyft. So it is getting out there. It is making its way into Indian country. But it just depends on where you're at. The other thing that you have to look at is not all tribes are land-based transportation. In Alaska, to get to Sitka or Metlakatla, you got to take a ferry, or you got to take a seaplane, or be a very good hiker, because there's no roads in or out of the community. So in talking to the tribes and knowing a lot of these tribal lands, what are their wants, what are their needs? We did a needs assessment. When this slide was made, I had only talked to 25 different tribes out of the 46 different tribes I work with. Because a lot of tribes, you have to understand the tradition and culture behind a people. We all have our own different traditions and cultures in our families, in our racial identity, in, you come to a college, you got sororities, you got fraternities, they have their own traditions and cultures. So you have to keep those things in mind when you're talking to tribes, especially because people think, oh, it's in the past. Boarding schools. I'm first generation, not forced to go to boarding school, only because my mother ran the bus off the road to save me from being sent to boarding school. There are still boarding schools today. So when talking to tribes, the last thing you want to say, history's in the past, because it is still very present. The other issue that brings on this kind of like standoffish between tribes and working with other entities is research. Literally, Native people have been researched to death. And I'll give you an example. My aunt, when she was 7 years old, she was in a boarding school. She was intentionally, as a healthy child, placed into a tuberculosis unit because they wanted to see how long it would take for her to go from healthy to being sick. The true story. She's still alive. She still has her kids. She tells us these stories because a lot of the people that went to boarding schools that had bad experiences are not going to talk about it. And you don't want to push them on it. So you have to be sensitive and cognitive to these ideas are still out there. There's still issues going on. When I talk to them, the top 3 had the most responses, but the bottom 3 had very strong conviction in this is what we need, this is what we want, and this is how we want to be treated. We want to be included. We want equity. We need the funding. Because some tribes, like I showed you, are treaty tribes, and they need to have those rights respected and enforced. Most of the time they're not. So, one of the things tribes told me, what technology is out there? Nobody includes us in explaining technology. What's available? Show us what we can use, but does it work here? Because you have to remember, a lot of these tribes do not have cell phone service in parts of their communities. Or if they're spread out across different state jurisdictions, you have different laws and policies over here than you do over here. So those are some of the issues that they're looking at. What technical assistance is available? Nobody's ever told us. How are we supposed to know that we can apply for technical assistance grants? This is an example that I'm using because when I worked at Yakima Nation, I applied for this grant. We got it. Yakima Nation, since I'm no longer there, I'm part of the TTAP now, is working on 150 miles of trail minimum for pedestrian safety corridor. Because pedestrians and motor vehicle crash fatalities, Native Americans, unfortunately, are number 1 in those being killed in either of those 2 categories. So I was talking about having respect and provide assistance during traditional ceremonies and events. These runners here, this culture still exists where they have message runners, prayer runners, warrior runners. An individual can easily run 100 miles a day, no questions asked. In 3 days, they can go 300 miles. In a week, they can go 800 miles. And me and 22 other individuals, our youngest one was 4 years old. Our oldest one, I think, was 68. We ran 1,998 miles in less than 3 months. And so when you're talking about transportation and your road users, we ran all the way around the state of Washington. And we had state patrol stopping us, trying to cite us, trying to fine us for running on the highway. This is another big one, the canoe journey. They just had the landing at Alki Beach this last summer. I can't even tell you how many tribes were involved. I know there was at least 50 different canoe families. Some tribes have more than one canoe family, and so that's why there was so many of them. But look at all of those people. They have asked the Tribal Technical Assistance Program for assistance with the road users, parking, congestion, landing, marine safety, all these little pieces that come into the puzzle. Complete streets and transportation. By whose definition? Tribes are still a very huge horse culture. I would see this at least every other week. Every week during summer, spring break, and winter break, because then you can have kids on there as well, traveling up and down the highway. So just kind of keep these things in the back of the mind when you're working with different communities is what's their common thread? What is the thing that they need to make complete streets? Because not every complete street is going to fit every community. And so there needs to be some flexibility, adaptability. Like I said, there's treaties. Keep the promises and uphold the treaties. The reason why I use this picture is because I know for sure in Montana, Idaho, and Washington, and Oregon, it was promised at the signing of the treaty that for as long as the railroads went through the reservations, there would be passenger rail service. There has not been passenger rail service for the Yakima, the Cayuse, the Nez Perce, the Crow, the Blackfeet. That's ones I can think of off the top of my head. Basically, Seattle to Chicago, however many tribes that is, has not had passenger rail service since 1981. Where's that in keeping the promise of treaties and obligations? So one of the big things that's come up where tribes are actually going, yeah, we'll dip our toes in research, is because of 6PPD. Almost every single tribe in Washington, Oregon, and Idaho, and Alaska, even the tribe in California, the tribe in California, we're all salmon eaters, mollusks, crabs. You have basket making materials that are in these watersheds where 6PPD is entering those watersheds. A lot of people don't think that tribes have foods in the waterways or the watersheds. There are plenty of foods and plants of usage that also need to be included in the training and the research on 6PPD. And tribes need to be included because if you don't include fishing rights, there's going to be a lot of trouble with a lot of different tribes because fishing rights are number one because of its subsistence foods. And so to show you how tribes came together, or at least one tribe, the UW Star Lab, the Northwest T-TAP, and WashDOT, Washington Traffic Safety Commission, Yakima County, these jurisdictions came together and worked together collaboratively, and they created a program that in its first year got the Federal Highway Administration's Build a Better Mousetrap Award. And not only did they get the Innovation Award, but they also got the Best All-Around Award. And at the National T-TAP and LTAP conference, Yakima Nation took all three awards because I also won the Logo Design Award for the T-TAP centers. So Yakima Nation cleaned house, but we did it in teamwork. And so I'd like to introduce Dr. Wong, or sorry, Dr. Sun. Wong's my boss. I'm still getting used to him being doctor, so. So Wei.
Thank you.
And this is why I forgot I added this last minute, because my sister said, you need to tell them why you're so passionate about this stuff. So I added this in last minute. I've worked 30 years in public safety. And I've been in 5 motor vehicle crashes where I was not the driver. I was a passenger. I've been in hit by a drunk driver, 2 rollovers, hit by a speeding dump truck. He didn't have any brakes, so it wasn't technically his fault. And hit by a farm vehicle. Now, if you've ever been in Eastern Washington and you see the tractors with the great big, huge, long trailers, I estimated 20 feet, but it might have been longer, and they have apple bins all in it. So they can't stop quickly. It's like pulling, like a semi-truck driver. 2 motorcycle crashes, got hit by a distracted driver, actually up there in Bothell area, and I was coming here, and then roadway departure due to eroding pavement. My brother was driving, I was in the back, and we hit a piece of the roadway that had been chipped off from farm vehicles and lumber trucks and everything, and then just loss of family and friends because of roadway incidences, whether pedestrian or motor vehicle. Okay. I'll let you.
Thank you.
Okay.
So thank you, Holly-Anna. So actually, Holly-Anna, she was the traffic safety coordinator of Yakima Nation. I think she's played a major role for us to collaborate for University of Washington. When I was working for UW, and we made the connection, but mostly because of Holly-Anna that lead to the UW team, to work with Yakima Nation to the DNR engineering team. Holly-Anna lead us to Rich, Pasha, Dwayne, the entire team of engineering, as well as the nice folks at Yakima Power, help us deploying different devices there. Yeah, so Holly-Anna, thank you for that. Yeah, so this, my presentation is mostly the one that Holly-Anna just mentioned that won the FHWA award. So that's the project that we deploy a MUST device. And also before that, we actually have a US DOT Safety Data Initiative project. So basically, the UW Starlab built a safety data portal for Yakima Nation. So with that project, we actually identified, in addition to building a platform for the tribe to use, existing data sources that they can get from different jurisdictions that Holly-Anna mentioned. But still, we figure out there are challenges for collecting data. That's where we have this new project, basically, to have a way for Yakima Nation or other rural tribal agencies to use some technologies and to efficiently and effectively to collect tribal-owned data sources. So that's basically the project I'm going to talk about. And also, again, it's a collaborative effort among all Yakima Nation, UW, AI Vision, PacTrans, Northwest TTAP. So this is the team members, Yakima Nation, Pasha, Dwayne, and also UW team. Holly-Anna just also became a UW team member as well. I used to be working for UW, now I'm the lead the AI Vision company. So we actually presented together a couple times before. This slide actually belongs to Holly-Anna. So I'm gonna just describe. Actually, Holly-Anna already mentioned a lot of challenges that tribes are facing. These are not specifically for Yakima Nation, but Yakima Nation are actually facing those challenges, if not even the worst among the tribes. At least in Washington State, Yakima Nation have the highest rates of both motor vehicle and pedestrian fatalities. But those are the things that are constantly changing. With Yakima Nation, the DNR engineers help, and with all the project, Watchdog's help building roundabouts, I think that actually changed the status. This was like a couple of years ago's data. I think last year, the crash rate dropped significantly because the building roundabouts. But still, there are things that need to improve, especially the things that we just mentioned, that it's very hard for tribal agencies and rural agencies to collect data. And data is important, as you see a lot, most of the urban agencies, they have deployed a lot of sensors on the road to collect data. That can be used for planning, but also for real-time data to support real-time decision-making. So what we're trying to do for the project is mostly focusing on one particular corridor, because you see the US 97, they have a very high rate of injury and also the fatalities. So this is based on crash data collected by Watchdog. There are 11 intersections and 10 corridor segments of this corridor from Toppenish to Union Gap. And these are some of the road conditions the Yakima Nation are facing every day. The rural road geometry with sharp corners, steep grades, and also with people walking on the roadside without a proper pedestrian facility. And also the heavy fog that with low visibility conditions are very common in Yakima Nation, and also snow and ice covered roads during the winter season. So those are some of the conditions that would require some technologies to collect and being able to monitor those conditions in real time to support decision making. So those are some of the things I wouldn't go into detail. Basically, those are the things that we figure out working on several projects. That's probably why you don't see a lot of traffic collection devices deployed on those low volume rural roads, but not just because they are low volume, less vehicle travel doesn't mean they are not dangerous. But if you're just looking at the crash risk, it may not be as high as in an urban area, but still, with some of the technology, we're able to detect the data set that can support and also to rate different risky level for those rural roads and support better planning of resources. And also some challenges that tribes are facing is the lack of personnel to really handle the data analysis, even if you have deployment, some devices there to collect data. And also through some of the project we're working with Yakima Nation, we really want something that's specific for the tribes because all the data currently right now is like separated by different jurisdictions. We think a technology can support like tribal-owned data set that would be better for maybe for Yakima Nation engineering team that they can use that data they collected directly in addition to have to ask for different jurisdictions and authorities to get those data sets. So yeah, that's kind of the background of the project. So basically, we're also funded by two U.S. DOT project that Yakima Nation is a partner with. So use that funding, we have a pilot, and also we're continuing building upon the pilot project to expand that to the entire corridor. So what we do is we deploy this MUST device. Is actually a research product from University of Washington and recently got commercialized into AI Vision. And also funded by US DOT and WashDOT. So this particular device can be just installed in a rural environment. And because as Holly-Ann mentioned, for a lot of locations that we deploy the device in Yakima Nation, that basically doesn't have all the infrastructure support that you normally see in urban environments. So power is the only thing that we can get, but even that is very challenging to get. With the help from Yakima Power, we are able to deploy those devices. But except from like power, it's hard for us to get maybe a reliable and also high-speed internet. So what we're doing is mostly relying on cellular communication. Okay, for transfer only the important data that need to be transferred to a center or to the road users directly. So what we do is for this device is do edge computing, meaning all the computing are happening within this device. It have the computing unit. So the sensors connect to this device are cameras, and Bluetooth Wi-Fi adapter for MAC stress detection, as well as like environmental conditions, sensors, temperature, humidity information can be gathered. And all are analyzed within this unit and just send out warning message or data to through the cellular communication efficiently. So this is the installation and deployment in Toppenish, one of the most dangerous intersection, the rural road and Highway 97. So because I only have 5 minutes, I'll just show you guys the core functions that this device can provide. So definitely it can do all the data collection that it needs on the roadside, like traffic, monitoring traffic, road condition, even road surface condition, like snow, ice, wet, dry, and also visibility condition to determine whether it's heavy fog. We can send warning message to a message board to warn the vehicles and also warn the pedestrians. And also we want to detect hazardous events. So we're working with the DNR engineering team in Yakima Nation to identify the most interesting events that we want to collect, like stopped vehicles, pedestrian movements around the area, heavy fog, weather conditions. Yeah, so this is a dashboard with the device deployed in Yakima Nation. You can, the DNR engineering team can see the data collected in real time, like traffic, road conditions, and also the historical data collected with a snapshot or video to validate the information. So with that data, we can do a lot of safety analysis. For example, we are able to identify the device works 24 hours all day and all days of the week. So basically, it can detect like pedestrian movements and also the movements of semi-trucks or agricultural vehicles, and also especially their interactions. So we are able to detect some of the dangerous conditions, those events, to warn the engineering team. Yeah, so those are some of the things we are specifically built for the rural environments, mostly to monitor the road surface conditions. So for some of the conditions you can see in those photos collected from this device, like it's mostly covered by snow, but still at the same time there are semi-trucks traveling, there are even pedestrian traveling. So those are some of the events we are able to pick up. And also the next step, we want to basically display those information in a message board. So we are able to communicate the information to a VMS sign on the roadside in real time, in addition to those dashboards. So basically we are working on this to build upon this pilot from one intersection to expand to the entire corridor. That just partnered with Yakima Nation and Watchdog, with Watchdog support, we submitted a smart grant for this, the enhancement for the US 97 corridor. Yeah, basically leverage the MUS device, as well as some of the Amazon's private 5G communication to make this corridor a safety corridor. Yeah. I think I mostly run out of time, but this is some of the things that we just proposed. And also, Holly-Ann already shows you the award we just won. So I think that's my last slide. So cool. Yeah. Thank you.
Just let you guys introduce yourselves. Yeah. I'm just going to let them introduce themselves because, like I said, I was supposed to be just the presenter, not a moderator. And I hate it when people butcher my name, and I don't want to butcher theirs. So.
Okay. Well, thank you for having me today. My name is Afsane Yabari. I'm a traffic engineer with UC Berkeley at SafeTrack. SafeTrack is Safe Transportation Research and Education Center. So for short, we call it SafeTrack. And one of the programs that we work on is the Tribal Road Safety Program. So that's what I'm going to be talking about. Okay, how do you, page up, okay. Okay, how do you change that?
Yeah, you should, no, this one right here.
Oh, this one.
There you go.
Okay, great. Okay, thank you. Basically, I just want to talk about SafeTrack and who we are. Our mission is to inform decision-making and empower communities to improve roadway safety for all. We are affiliated with School of Public Health and also Institute of Transportation Studies, and we have partnership with Department of City and Regional Planning. And most of the projects that we do is in collaboration with California Office of Traffic Safety and also with California Department of Transportation, or for short, PacTrans. So that's, they are basically the funder for most of our projects. I'd like to pay tribute to my late colleague. He was Dr. Ragland. He passed away last May. He was a pioneer in the tribal transportation project that we are working on now. He was the founder and co-director of SafeTrack. And I'm going to be, or some of the slides that I have here, you know, he and I work together, so I like to pay tribute to him. Okay, so the tribal transportation, the Tribal Road Safety Program, the TRSP that we have at SafeTrack. We offer different things, different programs and different tools as part of this tribal program. One of the main one that we do that I'm going to talk about, I'll talk about all of them today. The first one is the Tribal Transportation Safety Assessment, TTSA. The second one that I'll talk to you about is a tool that we have developed, Tribal Crash Data Tool, or for short we call it Tribal TIMS. And another one is Tribal Street Story Tool. And then also we provide resources and references for tribal agencies in California that they are free and they can just go to the link. And we have like funding resources and references for the roadway safety. And one thing that we have started recently is the online tutorial presentation that we are working on. And that is something that tribes can access on our website. We have 109 federally recognized tribes in California, and a lot of funding that we get from OTS or PacTrans, they require us to provide the services to the federally recognized tribes. There are just a few that there are not, but I guess they will be soon. So basically most of the tribes in California are federally recognized. And the purpose of this tribal road safety program is to improve transportation safety on tribal roads, as well as roads accessing the tribal lands. As Holly-Anna was mentioning, that there are a lot of roads, either the state road or county roads, they go right through the tribal lands, or they provide access to the tribal lands. So we try to look at those roads for safety, as well as the roads inside the tribal lands. So that's what the program is. So I'll start talking, okay. I'm going to start talking about the TTSA, the Tribal Transportation Safety Assessment. We have started this program since 2017, and so far we have completed 51 assessments. And every year they have been funded by different entities. A few times it was funded by California Department of Transportation, CalTrans. One time or 1 year it was funded by California Office of Traffic Safety, and another time it was funded by Robert Wood Johnson Foundation, RWJF. So every time we get these fundings from basically it's either from OTS or CalTrans, basically the funding is for 1 year or 2 years, and we do these TTSAs for the tribes. So the process is basically we advertise, or we reach out to the tribes in California, and we tell them that we are starting this program again, and we send an application to them, and they fill out the application. So basically the application just says that what are your issues, what are your traffic or transportation safety issues that you want us to look at, and what are the areas that you want us to look at. So in the application they just write what they want us to do, and we send one engineer or planner we assign to each assessment. So first we have an initial conference call with the tribal government representatives, and also if they like we can invite other stakeholders We have an initial conference call to talk about what are the issues that they want us to look at, safety issues, and also what focus areas in their tribal land they want us to study. So then once we have, we decide on focus areas and safety issues, then we plan on one-day site visit. So the site visit usually is in-person site visit. But during the pandemic, we started doing it virtual because during the pandemic, a lot of tribes, they were pretty much closed. So they were not letting anybody from outside to go. And nobody actually wanted to sit in some place with anybody else because of the pandemic. So we decided to do it virtually. So basically what we did was that we would set up a Zoom meeting, and then we would have the Google Map and Street View, and then talking to them, we would look at virtually the areas that they wanted us to look at, and they would tell us what the issues are, and basically that was what we called the site visit. But now we are back to the in-person site visit, in which we go there for one day, and we either drive the area that they want us to look at, or we walk. But then one of the tribal members or their government members is with us to tell us what it is that they want us to look at and what issues there are. And most of the issues that they have is, the pedestrian bicycle safety is one of the issues, as Juliana was mentioning. A lot of the roads, the tribal roads, they don't have any sidewalks, they don't have any crosswalks, and then like a PacTrans road or a county road goes right through it, and then actually divides the tribal land in two, so the kids have to cross the highway to get to school. South of it, they don't have school buses. So these are the issues that they have, that they want us to really study, to look at. And also the other thing is that some of the roads are not paved, but the ones that are paved, they are very narrow, and they're two-way roads, but they're very narrow, and they don't have any pavement marking, so that's why they don't have any center line, and you see a lot of head-on collisions on those roads. They don't have any lighting and no signing. So these are the things that we really look at, and we tell them what the issues are and what they have to do to fix them. As part of the study also, we do a community engagement because our funders, either PacTrans or OTS, they really want us to, 5 minutes, sorry. They want us to really, get the community engaged. So that's another thing, the community engagement that we have. So then after we do all of these, we provide the report. So in the report, we write the community engagement survey and what the people asked for. The crash data, I'm going to talk about the crash data tool that we have. So for the crash data, because we have a system for crash data for the state, it's called Sweeters, that has all the crash data. But we have found out that the crashes that happen within the tribal land, they are not reported, a lot of them. So therefore, there is no crash data. So that's another thing that I'll talk about, the tool that we have for that too. So basically, then we have we talk about the issues in the report, and then the funding sources also, we provide the information for them. So what they can do, the tribes, they can use this report in support of their funding applications to FHWA. So basically, FHWA has told us that these reports, actually, they can use it and put it behind their applications to apply for funding. The other thing that we provide, other than the TTSA, is TEAMS. That's a tribal crash data tool that again uses the Sweeters, the statewide integrated traffic record system. It has all the crashes, that are reported in California. But like I said, a lot of crashes that happen within the tribal land, they are not reported, so therefore it wouldn't show on these teams. So I go very fast. This is the application that we have. This is free to everybody. It's password protected. So the tribes, the tribal government members, they can ask to get access to this. And then it has all the information. And then, for example, this is one of the examples. That area is one of the tribes, and it shows the crashes in that area. And then that's a 1 mile buffer. So it shows that within the tribal land, there are that many that are reported, but then accessing the tribal land, which is, in this case, is Highway 101, which is a major highway, there are so many. So you can tell that, well, the tribal members are affected by those crashes that are not even in their area, but it's accessing their area. So this is one thing, and we have all the details on those crashes. Then these are the tools that they can use in the reports, or we use them in our reports. So that's the way to in support of the funding applications, they can use this or for any other research. I can give you the detail later if you want to look at this tool. It has all the information about the different crashes. And we did the time period that we asked for. So like it tells you about the fatality, if there were pedestrian involved, or even day of the week, how many were, like Tuesdays were the highest number of crashes. And it had this type of crashes also. The other tool that we have is Street Story, and that's a community engagement tool. That's a tool that people can use to either report any crashes that they have seen that has not been reported, or near misses or any hazardous areas, or they can look into it and see if there were any crashes anywhere. And that's, again, something they can use. It's a free tool that could be used for, for any research. And this is how, again, that's how the tool is. You put the name of the tribe, and then you can insert, these are the questions that comes out. You can add any information as much as you want. And that's how you can report an incident or a crash. And you don't have to give your name. So it's, you don't give any name or anything. You just add the information. So this is basically just collecting data, the data that's much needed for any work to be done. So this is the paper version, and this is how you can see on the tool, on the Tribal Street Story. That's what you get from there. This is, again, the graphs and all the tables that you can use regarding all the incidents or crashes that have been reported. These are the crashes that some of them have not been reported. So the CHP, the California Highway Patrol, doesn't have those crashes, but still FHWA uses those. So these are the information that you can see there. The other thing that I mentioned we are doing is the online tutorial presentation. That's a class that we are going to be working on, that any tribal members, they can actually apply. They can take the class. It's free, and it talks about all the things that we do for them, but they can do it themselves. They can find out how to get the crash data or how to collect crash data, and also the community engagement, how they can do that, and also how they can do an assessment themselves. And these are the things that they can look at, like, the countermeasures, like pedestrian bicycle safety audit, how to, like, where they can get information about pavement marking and striping, signing, and where they can use it. So basically, that online tutorial presentation would provide all that information. This is, again, the information. And also for the funding sources, that's very important, that a lot of tribes are not aware of the resources within FHWA, and we provide the information. And also we help them to learn how to apply for this funding, like, how to fill out the application. So these are the services that we provide. Okay, so this is my information, and then our website. And if you're interested in any of this, actually you can have a copy of my presentation, so you can have the link to all of this. Okay. Thank you.
Hi everyone, my name is Ed Kaloje. I'm a professor here at the University of Washington. I'm in the Environmental Science Department at the University of Washington, Tacoma, and I'm in the Civil and Environmental Engineering Department here at UW Seattle. And my labs are here at the Center for Urban Waters in Tacoma. And we work on water quality, especially chemicals in water that affect fish. And so my whole career I've been chasing chemicals around the environment that are bad for fish so we can figure out how to manage them. So today I want to talk about roads and water quality in salmon. We're going to say how we found this compound 6-BPD quinone, which is highly toxic to a bunch of salmon species. And more importantly, it comes out of a compound called 6-BPD, which is in everybody's tires. So we have to figure out how to manage that if we want good water quality out in the environment. So I'll start with a little background here. In the 1990s, basically the city of Seattle spent millions of dollars to restore our urban creeks. We wanted healthy creeks. And one of the criteria for success in those restorations that salmon would come back to those creeks and spawn and use that beautiful habitat that was built for them. Except it would rain, and suddenly, this is a coho salmon in Miller Creek right near SeaTac Airport. When it rained, the salmon that came back died. So they'd count these fish coming up in the creek. They'd see some healthy fish starting to, dig their nest, and then rainfall would kill the fish. They'd see the exact same fish like 50 or 100 feet downstream. So starting in the 1990s, people started to document, like, is this happening in one creek? Is this all over the place? They found that a whole bunch of watersheds throughout the Seattle area. This was happening to coho salmon in the fall, like right around the rainstorms this week. Killed coho salmon regionally here near Seattle. There's anecdotal reports from Bellingham going back all the way into the 1980s, so this has been happening for decades, and it happens in dozens of watersheds. In some of the most urbanized systems, the places where you're putting a lot of people, a lot of cars, and salmon together, coho salmon specifically, over 90% of the coho salmon would die before they had a chance to spawn. And that's absolutely super problematic for the populations of those fish, especially when we're literally spending billions of dollars to try and keep these fish around and support the economies and cultures that are built on them. More often, landscape modeling said that this was related to urbanization and busy roads specifically, but people did not figure out what it was, right? People looked at like all the usual things that kill fish, and none of them made sense. So I came to UW in 2014. Everybody was talking about this. I run a lab looking at like environmental pollution, environmental chemicals. I love fish. I'm a member of the fish tribe myself. I started working on this with the teams of people who had been working on this for the last 20 years or so. So we started to look at water where fish died. And we started to just make a toxicant signature, like what chemicals were around if fish died. And we identified 57, by the way, my instrument routinely detects thousands of chemicals in every single sample. We look at. But we look in these water samples either in the lab or out in the field. We had citizen scientists out there collecting them, and we'd find 57 chemicals were always present if fish died. So we started working on identifying what those chemicals were. And really interesting to us, right at the beginning, 9 of those top 10 chemicals were chemicals that we also saw coming out of tire rubbers if we ground up some tire tread and we soaked it in water. So we really started to see this really clear chemical evidence of chemicals that are used in tire rubber production out in the environment when these fish died. That told us roads were involved for sure, right? So it definitely made that link to transportation, and it really started thinking us about tire rubber. Like this compound HMMM here, it's actually what binds the steel tread to the rubber itself. Diphenyl guanidine is called the vulcanization accelerator. It actually cross-links the rubber to make it really strong and durable, right? So we started to see like really high concentrations of these in these salmon mortality events. That led to some toxicology research with my collaborator, Jen McIntyre. She's at the Washington State University Puyallup campus. And by summer and fall of 2017, we had found that, Jen's lab found that if we took the tire rubber leachate, so again, we grind up some tire tread, we soak it in water overnight, we basically dilute that and expose that to fish, it was toxic to juvenile coho salmon. So by 2017, we knew that something in that tire rubber was incredibly toxic to coho salmon, right? So we started to do all the detective work to figure out what it is. I'm not going to tell you about this. This is all a bunch of science and research. What I want you to see is this. In tire rubber leachate, my instrument is detecting more than 2,000 chemicals in there. And so we're trying to find this like one bad chemical or a couple bad chemicals in this really complex mixture of chemicals that come out of our tires and end up in our roadway runoff. This chart here took us 2.5 years. At the end of this process, we chemically separated this. We had a fraction, we had a little chemical sample that only had 4 chemicals in it, and it was killing those coho salmon. So we had gone from a 2,000 chemical problem to a 4 chemical problem. And it told us we should pay attention to this chemical formula, C18, H22, N2O2. That was the big giant peak that our instrument was seeing in there. So we had collapsed this problem to figuring out what that was. And we made a link between the chemical formulas to the chemical formula of this compound called 6-PPD, which is a very similar chemical formula. And we found some old rubber industry literature from 1983. This is basically looking at, they're trying to make tires more durable. And we find that same chemical formula, C18H22, N2O2 there. And so this is the only place in the scientific literature we're finding this specific chemical formula. So now we had a link between some chemical that was apparently killing the fish and this chemical 6-PPD that was used in tires, right? So we actually bought some 6-PPD. We reacted it with ozone, which is exactly what its job is in your tire. I'll tell you about that in a second. And sure enough, it made the exact same chemical formula we were looking at. The peaks all lined up, and when we gave that to the fish, it killed them. So now we could replicate the whole toxicity, starting with this 6-PPD industrial antioxidant sample that we had bought. And so anyways, the compound that was being formed is this compound 6-PPD quinone right here. So that's, I think, the first time I'll say it. So tire rubber is incredibly sensitive to the little bit of ozone that's in the air. This room has ozone in it right now. There's probably 50 parts per billion by volume of ozone in here. Even if you go to a natural pristine forest, there's still a little bit of ozone that forms in the air. And ozone is an oxidant. It breaks apart the rubber bond. So ozone damage creates all these tiny little cracks in a tire. If you look at a really old tire, it has all those cracks. That's ozone damage. And so the rubber industry has been working for more than 100 years to prevent ozone damage from tires. And Army chemists in the early 1950s, to allow us to basically fight the Cold War, to kind of stockpile our military vehicles in a warehouse and then take them out and use them if they were needed, if some sort of weird invasion happened. They actually designed this compound 6-PPD. It looks just like that right there. And it was an antioxidant. You mix 6-PPD throughout the tires, and then 6-PPD migrates up to the surface of the tire, and it's designed to react with the ozone and basically break the ozone apart before the ozone can damage your tire. So 6-PPD is an antioxidant, it's an antiozonant, it's a preservative for the rubber. 6-PPD is what allows your tires to last for 50,000 miles and drive all over the place and break and be durable and safe for you and your family. But when it reacts with ozone, it makes 6-PPD quinone, this compound right here, which is far more toxic than 6-PPD and is highly toxic to coho salmon. And actually, if you look at your tires, if you haven't washed them in a long time, they look a little bit of like a brownish red dust on them. You are literally seeing 6-PPD quinone on the surface of your tire. It gives them that little reddish orange color. That actually comes from this chemical right here. So it's one of the few chemicals you can actually see with your eyes if you know where to look. If you buy a new set of tires for your car, that's about 100 pounds of rubber, you're buying 1 pound of 6-PPD mixed into that rubber. And essentially, so all of us have a role in creating this. It's super toxic. I'm not even going to talk about that. In fact, actually I am going to talk about that. LC50 is how you measure toxicity, right? 6-PPD quinone has a LC50 value is what concentration kills half the exposed population. The LC50 value of 6-PPD quinone is 41 to 95 nanograms per liter. That's 3 different independent labs have now built those numbers. It's actually the second most toxic compound to aquatic organisms identified in the scientific literature. There's only one hardcore pesticide, parathion, which is probably a little bit more toxic than 6-PPD quinone. So it's super crazy that we have this really toxic compound that forms on everybody's tires. It's globally ubiquitous. It's in roadway runoff and tires everywhere. It's actually, you might have some in your shoe rubber, black soles, right? We're breathing it right now. It's probably in the house dust in this room, and if you stand near a road, you're definitely inhaling it into your body, and all of us actually have this component in our body as well. So we essentially identified a really ubiquitous compound that had a huge amount of toxicity to it. It's not just toxic to coho salmon, though they are the most sensitive species. Currently, we know it's toxic to brook trout, rainbow trout, which are actually steelhead, right? So steelhead populations throughout the Pacific coast are also affected by this roadway runoff issue. White spotted char, which is an Asian species. A little bit of data on a certain type of Atlantic salmon fry at a certain life stage has some toxicity, although probably not environmentally realistic. And currently, I also know of data that says that cutthroat trout and lake trout are also highly sensitive to 6-BPD quinone, which are also species that are going to be relevant to the West Coast here. So it's toxic to a bunch of species like salmonids. There are a bunch of species of fish which have no toxicity. It's not toxic to them, so it doesn't kill everything. It kills salmonids that need clean water. Here's what's important for us to know in a transportation context. Here's our LC50 value concentration right here. If you have roadway runoff from a busy multi-lane road, your roadway runoff is going to be probably 10 times higher than the LC50 value. Jen McIntyre's toxicology studies for years would show that you had to take roadway runoff from a busy road, you had to dilute it about 20 to 25 times before the fish started to survive. And that tells you how much treatment or management, we got to get concentrations in the roadway runoff that are currently up in this range down under here somewhere, or else we're going to have a toxicity issue. So that's the roadway runoff. These are receiving waters, places where the salmon actually live. And you can see the receiving waters are sometimes near or above the roadway runoff, which is why you have, certain watersheds where 20 or 30 or 50 or 70% of the salmon die after that rainstorm. So this is the current problem we're trying to manage. We have to figure out where in our watersheds we need to spend our treatment dollars. So this is an example. This is Miller Creek right near SeaTac Airport. We did a watershed survey. We collected samples all through the watershed during this storm. This location right here, you're actually looking at the guardrail to State Route 509 right there. And there's basically a pipe right in here. I know the picture's not that great. There's a pipe here, little detention basin, and Miller Creek's about 50 feet down. We think if you're a coho salmon and you swim right above this location here, you're probably going to survive the rainstorm. But if you stop downstream of this location right here and it rains, you're probably going to die. So this is probably the #1 place in Miller Creek. We don't have a ton of data yet, but this is an example of this location should be prioritized for treatment installation because that's really where your water quality starts to degrade. There are other areas you have to take care of in Miller Creek, but I'd start right there. So we need to do these types of studies, or better, figure out sort of traffic patterns, some sort of landscape modeling type thing. So, we don't need people collecting samples from every river in a rainstorm. That's not practical. But we need to figure out where in our watersheds we have problems that we can put treatment in. We need to understand a little bit of work about how high concentrations get and where. So we need to do some focused sampling of effluents and things like that to figure out this relationship between traffic patterns and traffic composition and how much 6-BPD quinone and other roadway contaminants are, how much roadway contaminant there is to fix. So we're kind of starting to work on that. We need to design better treatment systems, right? So a lot of roadway runoff treatment is designed to manage metals issues. So you use these cartridge type filters. That's pretty common. By the way, most roadway runoff is not managed. So, but in the places it's managed, it's probably managed with some system that looks like this. We collected a few samples from a system like that. Those are actually all over on the right side here. Looking at a bioinfiltration system, we saw really high removal of 6-BPD quinone. So the bioinfiltration is a system where you're passing the roadway runoff through compost and sand. It's actually going into the ground. Those are highly effective, but they struggle with capacity, and they're not scalable to a lot of places that don't have the land area. Those cartridge filter systems, especially ones that are using zeolite type media for metals removal, they're probably only removing 20 or 30% of 6-BPD quinone from the roadway runoff. So that's probably not going to be enough, and we need better cartridges that are better designed for organic contaminants. We need to figure out who's putting the rubber on the road. In particular, there's some indications that half the rubber that's left behind on the road comes from heavy trucks. So I think if you have like an Amazon warehouse or a big sort of delivery type facility, that's an area that probably needs to be managed a little more carefully and closely, because that's probably a hot spot. Electric cars might even double the amount of rubber that's left on the road because they have those high torque motors and all the regenerative braking. In the long term, tire industry needs to take 6-BPD out of tires and replace it with a non-toxic compound. That's the ultimate solution. But I think we're going to have at least a 20-year period. They say this might take 20 years. There's going to be at least a 20-year period where we're managing legacy pollution from 6-BPD, and we need to do a better job with our roadway runoff. So that's ongoing, but it's going to take some time. It's not just acute toxicity you have to worry about. Roadway runoff causes sublethal things. It affects, sorry, I went too fast. It makes fish smaller. It affects how their heart works, and it affects how their immune system develops. So even if 6-BPD is removed from tires, we should still treat roadway runoff. There's a whole bunch of problematic contaminants in there that need attention. I thank my group, all our sponsors, including some like Washington State DOT and Federal Highway, although most of our research dollars have come from EPA. And yeah, we need to think about when tires are close to water, that's a problem for fish. So that's all I have.
So we still have about 7 minutes if you have any questions for any one of the presenters here. This is your chance to ask them at being here as resources of how to network and collaborate and coordinate with tribes and work together to solve common issues and problems. Are there any questions?
You said the organic-based treatments were working. Have you took a look at rain gardens or some of the other types of similar treatments?
We're just starting that. We don't have an extensive data set, so I'm gonna work on a little bit of data and a bunch of intuition, right? That's where my answer is based. I do think the carbon-based systems, if using like the biochar, the activated carbon, the compost type things, if you give some water time to contact that, it's gonna work probably pretty well. So I would expect good efficacy in those. I worry a little bit more about the types of treatments that don't have a lot of carbon type surface in them and where the water moves kind of quickly. We need some optimization in those spaces the most, I think.
For your equipment, there are some areas there is no internet and do we have any solution for that get access to internet?
Yeah, so it's not exactly no internet at all. It's just like very weak signal, and it's and also happens from time to time that we may have some strong signal for a while, but maybe that turns into very weak signal. So that actually can be solved with the device that is outside this room. So we use the cellular communication, but we just transfer the most important data in real time using the cellular communication, and also because we have the computing unit within this device, and also storage to basically store several data within this unit. So we just pick the time that they have some stronger signal to send historical data to a server, but only just keep the most important ones in real time. So that can be done just to offload some of the communication efforts.
Yeah, for what, are you collecting at other locations? You worked with any other tribes or other agencies recently?
Yeah, we were in communication with several tribes actually. So basically for rural and urban we have different use cases, and with Haiyan's support we are actually expanding the current efforts recommendation, and then we're talking to several tribes in other states as well as a few cities like Park City, Utah, and also Tucson, Arizona.
Go with you and then you next.
First of all, Ed, great presentation. I learned so much, but my question is for the other folks. One thing that I gleaned from a couple of the things said is touches on the topic of data. and both collecting data, storing data in databases, and then I want to ask about open data, because I looked at some of the SafeTrack website about the safety data, and it sounds like the crash data might be collected by the tribe, but it's not put into a database. And Wei-san, you had a slide that sort of alluded to who's going to own this data, and I interpreted some reluctance to sharing data. And so I guess my question, because on the other hand, there's a huge push in transportation at lots of levels for more open data. So putting our data into databases and letting the world have access to it to learn things. So could any of you just explain a little bit more about the hesitancies and how we approach this issue of data ownership and sharing with tribal governments?
So there's multiple issues on data. So when you're working with states, usually the DOT gets the data for the whole entire area. And they haven't done a very good job of designating this is reservation land or tribal lands, and we need to collect specific data to those areas. This is the first time I've heard of California's project, so it might differ there. But the same thing, you have Cal State and PacTrans as opposed to WashDOT and Washington Traffic Safety Commission. But most of the federally recognized tribes who have federally trained police officers, that data is collected by the Bureau of Indian Affairs. And there hasn't been very good communication from the BIA to tribes in sharing that data with them. And so tribes are being told, you have this problem, but we're not going to show you the data. And so that was one of the issues that Yakama Nation had, was trying to get that data. Well, part of the issue is because of the whole restructuring of the Bureau of Indian Affairs, nobody knew where the data was. And so, and then you add on to that COVID and people retiring and people saying, you know, I don't want to do this anymore. And so then you have this kind of black hole of, okay, well, we don't know where they stored it, but we know it's here, but where do we find it? And so that's one of the things where DOT is stepping in, Washington Traffic Safety Commission is stepping in, at least for Washington State, to help solve that issue and close that black hole by working with UW Star Lab and working with Northwest TTAP. We're trying to help tribes get that information so that they have their own access to their own information. Because a lot of tribes don't want to share that information with the outside communities. But one of the things that Yakama Nation did is they had a tribal traffic safety committee. So they brought in WashDOT, the county, the cities, they brought in all the other jurisdictions, they brought in even farmers in the area, because a lot of the crashes involved farm equipment. And so to bring them all in to solve the issue and the problem. And that's one thing that I want to do here at the Northwest TTAP, is create that tribal traffic safety committee on this level, where we work with all the entities involved in Washington, Oregon, Idaho, California, and Alaska, and trying to help figure out how do we fill those data gaps, because that's a common thread amongst most tribes, is the data gaps. You can't get funding without data.
Yeah, that's the same case with California. In California, any crashes on any state or any public roadway, it's going to be collected by the police department, or and it's going to be reported to California Highway Patrol, CHP, and CHP puts that into a SWEDERS, the statewide integrated record system. So that SWEDERS has all the crashes, and SWEDERS has like codes for where the crash happened. Unfortunately, up until just a few years ago, they didn't have any code for tribal land. So if the crash happened on the tribal land, it would go to private land, and then it wouldn't be counted for anything. So recently we started, like a lot of people actually started to change that. So there is a code for the tribal land. So if the crash happens on the tribal land, at least it's it's obvious. But the other problem is that on the tribal land, CHP doesn't go to the tribal land to get any information. It has to be provided by the tribe to the CHP. And a lot of times it doesn't. One problem we have heard a lot is about privacy and the fact that there isn't trust between the government, the especially with state and the tribal governments. So those crashes are not reported. So that's why we are trying, like as the university, so it's like kind of between the state and the tribes, we are trying to build that trust so we can have them to report the crashes to CHP, so then we could have them on, and the tool that we have, Teams, basically has all the crashes. So the problem we have is that it doesn't have all the crashes that are happening within the tribal land. Some of the tribes, they do have enforcement people, but the enforcement people, they are not responsible for collecting traffic crashes. They're like, they're enforcing other issues. So there is a big gap in the crash data in tribal land. That's the thing that we are trying to remedy and do something about.
So I don't want to keep you guys over. If you still have questions, because I want to respect your lunchtime and your break, and so, but if you have any questions, you can come up here and we'll make sure that you get the information at a later time. Because as we can see, it's obviously a huge issue. Thank you. Oh, great.